10 ancient engineering feats that still baffle science, myth or explained? I invite you to join me on a myth versus fact countdown as we move from the known to the nearly unbelievable. In this quick 10-minute deep dive for YouTube, we will visit deserts, mountains, coasts, subterranean cities to examine the ingenuity of our ancestors. I will guide you through wonders that have persisted for millennia, juxtaposing historical accounts, archaeological evidence, modern engineering insights. We begin with grand stones and end beneath the earth. Between them, devices, recipes, roadways that have shaped civilizations. My narration will state the facts we accept, present the leading theories that scholars debate, and pause on the enduring questions that still spark wonder. I stand before the Great Pyramid and marvel, as generations have marveled, at a structure composed of some 2,300,000 stone blocks, each quarried, transported, and set with near impossible precision. Its sides are aligned to true north with an accuracy that has baffled surveyors for centuries. A monument of limestone and granite, built around 2560 BCE, with chambers and passages that testify to a mastery of geometry and organization. Massive ramps of earth and brick, a system of internal ramps winding skyward, lever systems using counterweights, immensely coordinated labor forces. Experimental archaeology shows large stones can be moved and positioned, and replicas help us understand the logistics of supply, quarrying and workforce management. Yet the unresolved question remains acute. How were the heaviest stones, especially the granite blocks inside the king's chamber, lifted and placed with such tolerances, millimeters over tens of meters, without iron tools or advanced metal machinery? The alignment to celestial north suggests careful astronomical observation and surveying methods that rival modern instruments in precision. The Pantheon, ancient harbor's whisper of a lost material science. Roman concrete. The Pantheon's unreinforced dome has stood for nearly 2,000 years, testament to the Romans' mastery of binder, aggregate technique. The facts: volcanic ash, lime, seawater, were combined to produce remarkable resilience. Pozzuoli, pozzolanic ash and other sources reacted with lime and seawater to form crystalline structures. Microscope view: crystals preventing microcracks. Coastal breakwaters: seawater encouraged aluminous tobermorite and other binding minerals, strengthened the concrete over time. Marine-induced healing. Contrast: modern Portland cement, chloride-induced corrosion of embedded steel, decaying microstructure in aggressive environments. Modern engineers study Roman mixes not to copy wholesale, but to understand mineralogical pathways for durability without corroding steel. Labs have replicated some durable mixes, mortar grinding and lab testing. Exact recipes, proportions, on-site practices remain uncertain. How Romans managed curing, sourcing specific ash deposits, adapting mixes for different applications, reconstructed from mortar fragments and experiments. Myth versus fact. Scientific sleuthing has illuminated core processes, practical details still remain. High on a ridge above the Urubamba River, Machu Picchu reveals terraces, plazas, a concealed mastery of hydraulics. The Inca achieved remarkable drainage, a mortarless stone fitting, finely cut stones, gravity-fed channels, an integrated drainage network, preserving foundations and agricultural terraces, porous layers, stone-lined channels, subtle slope engineering to manage runoff stones fitted without mortar, interlocking faces resisted slippage, permitted movement during seismic events. Seismic resilience is not accidental. Modern engineers study these elements as lessons in passive water management and earthquake adaptive design. How did builders survey steep terrain with consistent gradients? What maintenance regimes sustained the network? Myth versus fact. Many elements are visible and explainable, yet daily hydraulic practice keeps a layer of mystery. It remains a living classroom for resilient mountain architecture. Recovered from a shipwreck off the Greek island of Antikythera, this corroded bronze assembly astounded scholars. a complex series of gears capable of predicting eclipses, tracking lunar and planetary cycles, and encoding calendrical information. Detailed X-ray tomography and reconstruction reveal differential gear trains, pin and slot mechanisms, and inscriptions that map to the Metonic and Saros cycles. In function, it resembles a mechanical analog computer. Manufacturing such a device required fine metalworking, knowledge of gearing ratios, and design principles that suggest workshops or individuals with extraordinary expertise. Yet gaps remain. We possess only fragments, and while sophisticated reconstructions reproduce its known functions, we still debate the full extent of its capabilities, the exact manufacturing techniques, and the social context. Who commissioned it, and for what precise use? Was it a unique prototype, or part of a tradition of instrument making now lost? Thus, the Antikythera Mechanism sits at the edge of myth versus fact. Science has decoded much of its function and engineering, but mysteries linger about its manufacture, dissemination, and the intellectual world that produced it. Greek fire, used by Byzantine navies, is the stuff of legend. A substance hurled from siphons that burned upon water, turning sea battles into scenes of roaring flame and horror. Contemporary chronicles describe its effect with reverence and terror. The core fact: an incendiary mixture that adhered to and burned on ships and seawater. Historical accounts point to ingredients like petroleum, resin, quicklime, sulfur. Delivery systems ranged from pumps, pressurized siphons. The tactical advantage was enormous. A psychological weapon, a physical weapon that could rout fleets and fortify harbors. Modern chemists and experimental historians have proposed plausible recipes, mixtures that ignite spontaneously on contact with water, or that sustain combustion in maritime environments. Nevertheless, the exact Byzantine formula, the proportioning, and any catalysts remain undocumented in surviving texts. Secrecy was likely deliberate, leaving us with educated reconstructions, but not certainty. In our myth versus fact ledger, Greek fire leans toward the explained in principle, yet the precise ancient recipe remains an alluring, dangerous secret from the past. Stretching across the Peruvian pampas, the Nazca lines form animal figures, geometric shapes, and vast straight lines, visible fully only from the air. The facts astonish. Some figures span hundreds of meters, carved into the desert by removing dark pebbles to reveal lighter earth beneath, remaining largely intact for over 1,000 years. Archaeologists explain the precision through planning, use of grids, ropes, and simple surveying tools. Ground-level markers and scaled layouts can produce large images when teams follow careful measurements. Ethno-historical analogies show how pre-modern societies used such techniques to create large-scale patterns. Yet the scope and clarity provoke questions. How did creators ensure proportional fidelity across distances without aerial vantage? And what social or ritual imperatives demanded such enormous public art? Theories span astronomical calendars, ritual pathways, and messages visible to deities or ancestral beings. Experiments recreate the lines with limited technology, suggesting that method, not magic, explains their geometry. But the cultural rationale and complete construction sequence still invite debate. Thus the Nazca lines present both fact and enigma. The methods to create them are largely reproducible, while the reasons and full planning processes, the intentionality behind each figure, remain partly veiled in the deserts of time. Chapter 7. Stonehenge's stones traveled extraordinary distances. Locally sourced sarsens, bluestones, dozens to hundreds of kilometers away. Monoliths weighing many tons, set in complex concentric arrangements, aligned to solar events. A record of movement, placement, cosmological orientation. Proposed transport methods include rolling logs, sledges lubricated with animal fat, sledges lubricated with water, dragging along prepared trackways, moving by river, moving by sea. Each hypothesis has supporting experiments. Teams have moved large stones using timber rollers, coordinated human effort. waterways may have eased the burden for certain fragments. Still, doubts persist. How many people were involved? How were routes chosen and maintained? How did prehistoric communities organize labor across seasons? Recent landscape archaeology reveals networks of causeways, quarries, processional avenues that suggest a broader ceremonial landscape. Combined with wear analysis and tool marks, these findings piece together a sequence of extraction, procession, emplacement. Yet some transport feats strain credulity without a complete inventory of techniques. Chapter 8. Roman roads. Stretching some 400,000 kilometers when including subsidiary paths, showcase a standardized layered engineering approach that supported armies, trade, and administration. The facts: multi-layer substructure, cambered surfaces for drainage, durable surfacing materials. Systematic surveying produced routes that endured centuries. Typical construction used a compacted bedding layer, coarse aggregate, screed, stone paving, with ditches and drainage works alongside. The Romans understood gradients, materials selection, maintenance, principles that ensured efficient load distribution and minimized water damage. Their achievement was not only in materials but in systems, milestones, way stations, legal frameworks for upkeep. Engineers employed tools like the gromer, corrobots, enabling remarkably straight roads across varied terrain, improving connectivity and state capacity. Many principles of Roman road building remain in modern civil engineering. Layered profiles, drainage priorities, attention to foundation work. Chapter 9. Across Japan, ancient wooden pagodas and temples survive centuries of tremors through an elegant marriage of material and joinery. The facts: interlocking wooden joints, flexible columns, central pillars permit movement without catastrophic failure. Traditional carpentry employed complex joinery, mortise and tenon, scarf joints, interlocking brackets, crafted without nails, allowing timber elements to slide and absorb energy. Pagodas often incorporate a central shinbashira, a core column that stabilizes sway and dissipates motion. The flexibility of timber, layered eaves, damped mass distribution reduces resonance with earthquake frequencies. Craftsmen tuned proportions and joinery to create predictable, recoverable deformations rather than brittle collapse. Modern engineers study these systems for bio-inspired seismic design, base isolation, energy-dissipating connections. Adaptable structures echo ancient wisdom. Chapter 10. Beneath the surface in Cappadocia lies Derinkuyu, an underground city carved into soft volcanic tuff that could shelter thousands and reach many levels deep. The facts are staggering. Living quarters, stables, communal rooms, wells, ventilation shafts, defensive stone doors, a comprehensive subterranean urban plan. Ventilation shafts demonstrate an advanced understanding of air circulation. Communal spaces suggest planned provisioning. Storage suggests long-term provisioning. Security features include rolling stone doors, narrow corridors to hamper invaders. Strategic thinking mixed with daily life. Carving the city required labor, tools, knowledge of the rock's mechanical behavior. The tuff is soft, yet stable when excavated to the right proportions, allowing expansive chambers without collapse. Artisan masons likely controlled wall thickness, pillar spacing, room layout, following empirical rules. Yet many mysteries persist. How was lighting managed? How were logistics handled? How was waste managed at scale? What social organization coordinated construction? How long did it take? Motivations are debated. Refuge, storage, religious practice, and the chronology is pieced from artifacts and stratigraphy. As our final myth versus fact entry, Derinkuyu shows engineering solutions in ventilation and defense, but the magnitude of coordination,